My name is Gilbert Gaboutloeloe. I am the head of Agriculture and Biosystems Engineering here at BUAN. I'm also a professional engineer registered with the Engineers Registration Board as a practicing and a professional engineer. I'll be taking you through the tour of our renewable energy, soil and water, and a process engineering lab. I'm naming this lab in that fashion because it has a mixture of instruments in those spaces. So we start with the ion exchanger, which is used for ion exchange in wastewater treatment, or just water treatment if you want to remove some ions. Use ion exchanger. It has some labs that come with it that illustrate how it works. Then we have the Bernoulli principle equipment here for open channel flow, energy conservation. It also has a board here that illustrates the different sections of the flume, where you can analyze the energy levels, and it basically just demonstrates energy conservation there. This piece of equipment here is for pipe flow friction losses on junctions, different types of junctions, wire junction, kerfed junction, sharp junction, constrictions, expansions. When two pipes are connected of different diameter, whether it's increasing diameter or decreasing diameter, it's analyzing the friction losses. So we measure either side of the junction so that we can compare the two energy levels and calculate the amount of energy lost in between the junctions. In fluid mechanics, this piece of equipment here complements the last piece of equipment that we just went through there with looking at the pipe friction losses under laminar and turbulent flow. In water flow analysis and evaluation, besides free water flow like we have just touched on the other piece of equipment, we now have water flow through porous media. Porous media like retaining walls, for example, dam walls. We analyze how water seeps through dam walls and the impacts that it can have in the integrity of the structure. Whereas on my left here we have groundwater flow, which we know also happens through porous media. We demonstrate how when you pump water from underground, what happens to the water hydraulics is also demonstrated here. So these two pieces of equipment is water flow under saturated conditions through porous media. In this room here we have two pieces of equipment for wastewater treatment. Activated sludge system on my left, which is similar to what we have in Glen Valley here in Gaborone, and fixed film system on my right here, similar to what we have in Palape wastewater treatment plant, if we were to maybe visualize it at a larger scale. And the two equipment on my right and left here, one on the left feeds the activated sludge system, on the right feeds the fixed film system with the effluent that you may wish to analyze to see how the two systems treat wastewater. So we have flow controllers here that control the rate of flow so that we can vary the rate of flow and see different residence times in the systems and the amount of treatment that can occur. On the systems themselves, we have control panels where they control all the system in terms of temperature, in terms of dissolved oxygen, and all the other variables that we may want to analyze or assess. We also have, at the bottom end there, we have settling tanks where you're going to separate whatever is being synthesized as water goes through the treatment for separation purposes. Then we have storage tanks at the bottom there where you can collect samples to analyze what could have improved water as it comes from the supply line. This piece of equipment here, activated sludge process, has got a control box where the processes can be controlled at different substations along the process line, and there's a play gear also that explains what actually happens in the different components. Then you can set whatever you want to run here, the rates of oxygenation of the water column, the temperature, and the rate we switch between different sub-processes. We have anaerobic and aerobic processes, and we switch the water sample in between for different bioprocesses. This piece of equipment here, like I said, it's for a biofilm process. It also has system controls, and the two pieces of equipment can be used mainly for research and also for teaching. But because it has a lot of system controls, you can vary the different flow rates, you can vary the return sludge and all that, so that you can have different variables. It also has attached film material here which can be changed to any locally available materials, because all you need is surface for bacterial films to manifest, and therefore you can check eggshells, you can check concrete, you can check gravel, you can check whatever materials with surface where a bacteria can manifest, and check how they effectively treat water as it trickles through. And like the other equipment, unlike the other equipment, this is analog, whereas the other equipment is digital, but all the system controls are here. And it has a plate here which shows the path of water flow through the system, so that one can be able to see all the pumps, all the valves, so that they can system control when the system is running. In going through this equipment, we did mention that the equipment is for both teaching and research. Some equipment is basically skewed more to teaching, and some is skewed more to research, whereas others are meant to do both. And from this training, we train students who come out as entrepreneurs in the spaces of irrigation or food production through irrigation with the water equipment that we have shown you, and also the energy equipment that supports energy that we need in the water sector. We also have this acumen as well covered, so that we have a well-rounded graduate who can go out there and be able to run their own solar systems that run groundwater flow from boreholes, and also be able to manage their energy through water reticulation in their irrigation systems. We also have process engineers on the side, which are not necessarily connected to the other three spaces of porous media, water flow through pipes, and renewable energy, where now we can have entrepreneurs who can go into having alternative sources of energy.